Hello students, welcome to the lecture on decision analysis. We are in the module 6. We are seeing the various factors that influence the decision quality. We started with meta decision as a part of framing, and then we went on to understand the framing. Then we discussed about alternatives, right? Now we are discussing about information, because that's a sequence in which you do. First you get a sense of what's going on, then you frame the problem, define the objective, then you look at the alternatives, and once you identify the alternatives, you have to decide which is the best. For that you need to gather information. So we are talking about information gathering now. I have taken a slightly unconventional route when we are discussing about the information gathering. I have taken this particular thing from a book on decision traps by Edward Russo and Paul Shoemaker. Okay, so this is about smart information, what we call as the smart information, but this is different from the conventional smart information that you would have studied in MIS or in your training programs and things like that. Before we get into understanding the smart information, how to gather the smart information, let us understand the 3 traps when we are gathering information. So I thought first we would start with these traps so that we can avoid them. Shortcuts, relying inappropriately on rules of thumb is one trap. We have discussed about rules of thumb, which we defined as heuristics, also known as heuristics, and we also studied as to when to use heuristics, right? But there are situations when you should not use heuristics. For example, you will use heuristics when you have innumerable alternatives, you don't know the consequences, the probability of them happening is not known, and then you don't have time to analyze all these things even if they are available. In such situations you will use rule of thumb, heuristics. But when you have to do a planning, that is, you have sufficient time that you need to do planning, and you have sufficient amount of information, and the situation is a risk situation and not a uncertainty situation, then you should not use rules of thumb. So this is one trap. Right? We will talk about it a little later very implicitly. And then the next one is implicitly trusting. That is, if you have an information, okay, based on the availability of the information, you simply taking that and then using it as the right information is what is known as implicitly trusting an available information, and that is what is known as an availability bias, is what we have studied. Okay, and the last one is like the anchoring, which we have studied a lot about anchoring. So these are all the 3 traps in the information gathering. Now let us get into the smart information. There are 5 steps for smart information, or 5 different elements to smart information. Though I have organized them as steps, they are actually not steps, but they are 5 important features of a smart information. Okay, we will look at each one of them. Level of confidence, calibration, disconfirmation, expecting the unexpected, and the right information. These are all the 5 distinct features of a smart information. Let us look at each one of them. I have tried to organize them into some small interactive sessions, but we cannot do an interactive session over a recorded lecture, so I am going to just administer it in this way. Right. Look at these questions. I have given 8 questions here. Okay, and you have to give the estimate, your best estimate for answer for each of these questions. Some of them will be known to you, so if it is known to you, no problems, just write what is known to you. And some of them you will not know, so you have to estimate. Don't Google, just estimate. Okay, one correction is that this weight of an empty Boeing 747 should be in tons, not in kg, okay, because the answer that I have given is in tons. So go ahead and then pause this video, answer these questions, and then wait for the next slide. Now, now hope you have paused the video and then you have entered the answers. Just keep it with you, and then now I'm gonna ask you a set of questions here. The first question is that what was your estimate? You might have given one estimate. For example, Mother Teresa's age at the time of her death, you might have given something like say 82. Okay. Did you give a range or did you give a point number like 82, 83, 85 and things like that? If you know the answer, then there is no problem. But if you are estimating, then did you give a single number or a range? That's the first question. If you have not given the, sorry, that's the second question, okay. If you have not given the absolute number, but you should, if you have given the range, what is the range within which you have given that, okay. And what is your level of confidence for that range? How can we improve the level of confidence or narrow the range? You know that if you widen the range, then your level of confidence will be significantly high. For example, if you have given the range of Mother Teresa's age at the time of her death, anything between 60 and 100, then your level of confidence will be 100%. But you know that that's a too large range. So if I ask you to reduce the range, okay, and not compromise on the confidence to a great extent, instead of 100% confidence, suppose I allow you 95% confidence, what would be your range? And suppose I ask you at a 90% confidence, what would be your range? So if I ask you like this, and also ask you one more question if it is possible, in certain cases, what is the probabilistic distribution the metric will follow? If you can say this, then we can find the level of confidence more arithmetically. So if you can answer all these questions and then rebuild the same answers, like instead of giving one particular number, if you give a range and then confidence, now you can pause this video and then try to update this file, the table. Hope you have paused and then updated it. Now I am going to the answers, the actual answers. So now you have produced two tables. The first table where you didn't give a range, and the second table where you gave a range and a level of confidence. Tell me which one is has the maximum number of correct answers. Obviously your second table would have the maximum number of correct answers. So what does it actually mean? You can improve the accuracy of your estimate if you work on range and confidence level. You can argue that a particular number and a range, if that particular number is going to fall within that range, how does it really matter? It does matter because when you have a range and a confidence level, your finance guys or your quant guys will be able to conduct a scenario analysis. Whereas if you give a single number, then they will not be able to conduct a scenario analysis. So your accuracy of prediction will substantially improve if you work with a range and confidence level. So that is the first point. The next one is about calibration. When we say calibration, we are actually not meaning an instrument that you will take to a laboratory and then compare it against a standard. We are not talking about that. This is about calibrating our own estimates. Okay. For example, Shell does it pretty well. Okay, what they do is like this. I'm not too sure if it is happening in India, Shell in India, but in US it happens where they have to find the right place to drill for oil. And to find the right place, you have several parameters, the geological parameters. And all those parameters you cannot fit them into an equation and then find out as to what is the best estimate of finding the oil in a particular location or not. It doesn't work that way. It is a tacit knowledge. people gain that tacit knowledge over several years of experience. But you know that you can't be scaling up an operation if you depend upon experience. So obviously what Shell has to do, they have to recruit young geologists and they should be able to estimate. So what they do is that all the previous finds, okay, the oil finds, when they make a drill, whether the oil was found in that location or not, is recorded into a database. And then all those parameters that influence that find is also recorded. Now when a fresh GET comes, I'm just saying a fresh GET, when a fresh GET comes, he is allowed to go through that information and he is asked to estimate what is the probability that we can find oil in this particular location. Then he has to make an estimate and then he has to just enter that, the probability. Then it will tell whether the oil was found in that place or not. So his understanding, his tacit knowledge gets calibrated with this information. So when he does again and again with multiple tries, his calibration, his pattern will get calibrated and he will be able to better his estimates. And this can be done in the case of banks also, where to understand the creditworthiness of a borrower. What are all the various factors that you should consider in order to estimate the creditworthiness of a borrower can also be done in the same way like the oil find. So this is about calibration. The third one is the confirmation. Like I'm just giving you a very simple case which has been picked from that book. In a stock taking, inventory stock taking, they find that there is a high value item missing. So what will be the immediate response by the management? They would think that there has been a pilferage. Somebody has stolen the material. So they will immediately increase the security across the plant. So they will be spending a lot of money in increasing the security. But actually what happened was, when they went and reported this loss, the manager of the plant asked one simple question. He asked the question, okay, tell me, if you are losing so much of money, how much of volume of material has been stolen? Can you convert that into kg or volume or something like that? When they actually did that, they found that it would be several trucks of loads. So obviously you know that such a pilferage cannot happen. So they went back and then checked that, they found that it was a wrong entry into the computer. So by asking disconfirming questions, you can actually eliminate a bad estimate. Okay, so this is the third one. The fourth one, expecting the unexpected. Okay, availability bias prevents us from seeing the unexpected. Because you get to see something available, some data is available, and with that data you will try to work. And you will ignore any other hidden data or the data that are not available to you. So how do we do that? We can do it in three ways. One is fault tree analysis. You know, a fault tree analysis considers all probabilities, because if you have to add up all of them, it has to end up with one. So you have to consider all possible occurrences of the fault. Okay, so that is one way of doing. The second one is the scenario analysis. Like you will look at the best case, worst case, and the most likely scenarios and things like that, and that can also take the complete spectrum of the incidences. So that is the second way. And the third one is something new. The other two, fault tree analysis and scenario analysis, you will be knowing, but the third one is the prospective hindsight. And this is an important new concept that we are introducing, and this is also known as pre-mortem. Okay, Gary Klein of Harvard has actually coined this term called pre-mortem, and there is a video available here. You will watch this when I place this slide, and this is the pre-mortem of Gary Klein, talked about by our Daniel Kahneman. Okay, so what is this pre-mortem? Actually, I will explain that to you with a simple case. Actually, there's a real case, very interesting case. I have just taken it from the internet, so I'm going to more or less read it to you. Okay, you know Alfred Nobel. Alfred Nobel who actually invented the dynamites and things like that, and he was known as the merchant of death. Okay, and this term, the merchant of death, came into being. It was given to him due to Nobel inventing and making most of his vast fortune of dynamite and other types of explosives such as ballistite, which was the precursor to quite a lot of military grade explosive devices. Okay, so what happened was that once when he got up in the morning and then looked at the newspaper, a French newspaper reported that Alfred Nobel had died. Actually, the person who died was Alfred Nobel's brother, Ludwig Nobel. Okay, and what he saw in the newspaper, this is how it was reported: the merchant of death is dead. Dr. Alfred Nobel, who became rich by finding ways to kill more people faster than ever before, died yesterday. It was what actually reported by the French newspaper. But what actually happened was that his brother had died. So he actually woke up to a new morning. So if I die, and this is what the newspapers are going to report, how badly I would be known in the world. And then he started thinking about it, and he commissioned the Nobel Prize after that. So this is what is known as a pre-mortem, which means that even before you die, you actually face the death situation and then take actions against about it. So for example, let us look at this simple example. Okay. If you are running a project and you have actually discussed the project with all the people, and the people give a thumbs up saying that yes, this project will go ahead and then we are going to do it well. So at that point of time, more or less you have decided you are going to ask this question. Okay, just assume that we are going ahead with this project, and then we just go out of this place and then come back after say 3 years, and then we find that this project was a colossal failure. Then now all of us are going to sit and create that situation in our brain, in front of our eyes, and then write what are all the various ways by which it has failed is what we will write. So when they did it, actually when they do it, they can find a lot more possibilities than just by thinking that okay, what are all the ways in which this project can fail in future, kind of that sort of a question. So this questioning and this slightly reframing the whole situation helps in doing this. And let us I will ask you, this can be, you can relate it much better. For example, suppose I ask you this question. Okay, try listing what mistakes you might make in Compre. Now you have completed your mid-semester. Suppose I ask you this question, like what are all the various mistakes that you are likely to make in your Compre examination paper? So you write the list of things. Now I ask you to create one more list wherein I am asking you what are all the various list of things that you, what are the various mistakes that you have made in your mid-semester. And you will find that your first list will have more possible failures than the second list. Because the second one, which is about the past, the one which has just ended, you would not have thought about many other things. Whereas if you are looking through the future, then you can think through a lot more things. And that is what is known as pre-mortem, a very powerful tool. Okay, and then the last one is the right information. There are 3 points here which are very, very important. Information is costly, data is not. With our current big data and things like that, data is not expensive. You can just get it at the tip of your finger, whereas the information, which is a conversion of those data into sensible prediction or estimate, is what is costly. And that is where the entire business data analytics lies. And that is the reason why it's so expensive, right? The second one is more data is not more information. You can have volumes of data, but it need not be more information unless otherwise you know to use those data correctly, or those data are really credible. Right. The third one is more data do not increase accuracy of estimate. We spoke about this even while framing, that I said that framing is something, a bad frame can, a lot of information or data cannot compensate for a bad frame is what I mentioned to you. So now let us look at an interesting study conducted by Oregon Research Institute. What they did was that they picked a set of viewers in a horse race. Okay, and they asked them, okay, I am going to give you 5 information about this race, about some of the horses, some of the jockeys and things like that, and I'm going to give you the wind direction, all that. I'm going to give you 5 such information, and you have to estimate who will be the winner. Okay, and they asked this question, and also they said like, okay, I have given you 5 information and you are estimating something, and I want you to tell me as to what is the confidence level that you have. So they have just plotted it here. First they gave 5 information, right, and then they estimated their confidence level to be this. Just assume that it is some 16, 17, I don't know what is this, but what is the percentage of that, just some number here. Okay, it's a relative scale, so it's some number they gave. Then they allowed the race to continue, and then they found that this was the actual prediction. Okay, this was the actual case. Now what happened was that they gave them 10 information, additional 5 information they gave, and then again asked the same question. Now you predict and then see what is your confidence level. Then they gave a better confidence level. The confidence level increased, but their actual performance did not improve much. It was very marginal. Then what they did, they doubled the information. They gave 10 more information and then asked them to estimate. Their confidence level increased, but their performance did not. And this is what is very interesting, that they doubled that also. They gave 20 more information and then asked them to estimate with a confidence level. They gave a very high confidence level, and then you can see that their confidence level has nearly increased by 40%, but their actual performance has actually dropped here. So just an increase in information does not guarantee an increase in accuracy. Okay, so these are all the various factors that you need to consider in order to create a smart information pack. Thanks for watching.